Hello and welcome to the Tech Hearth. I'm Ryan, and today I'm going to show you how to set up the Lilygo T-Beam for use as a Meshtastic client node. I'm additionally going to be setting it up to send and receive messages via the public Meshtastic MQTT server, which will allow me to extend the mesh in my area to include messages sent from elsewhere in my state. This is part of my series on setting up a Meshtastic mesh so that I can still communicate with friends and family in the event of an emergency, or if there are issues with the cell or internet networks. Within this mesh, these Lilygo devices would be at the edge and would allow my friends and family to connect to them with Bluetooth to send or receive messages. The T-Beam is great for any situation where it does not need to be powered via battery for extended periods of time. For my plans, I intend to leave these plugged in, with a backup battery for if the power goes out. They're based on ESP32, so unless you have a robust battery power solution, it's less suited for a solar installation. You can make it work, but you'll need a more powerful solar panel and larger batteries than I'm planning to be using in my setup to ensure it can stay online during an extended period with cloudy skies. The T-Beam has a single OLED display, 3 buttons along the bottom, along with a micro USB jack that can be used for both serial communications and charging, and a small antenna connector. It also includes a GPS antenna and an integrated battery holder in the back, which is sized for a flat top 18650 battery. It also has Wi-Fi built in, which is part of why I chose it for this installation. The T-Beam includes an antenna, but I'm replacing it with this one here. This default one is fine, but this one has better SWR, which means the signal should be transmitted more efficiently, which should also translate to better range. Okay, before we do anything else, we're going to go ahead and install the T-Beam in a case, so it's protected from accidental bumps, drops, and damage. I've selected the wonderful 3D printed case created by Tony G for my deployments, and it's linked in the description if you'd like to use it as well. We're going to use 4 4mm M2 screws to secure the board in the frame, and then 4 16mm M3 cap screws, along with M3 nuts, to secure the front and back together. Use care when assembling it and ensure you've removed all of the support material from your 3D print so you don't crack the OLED screen. I did that with one of mine, and the top rows of the screen no longer function. That's not a huge deal for me based on how I'll be using it, but I might be atypical in this regard. Also, make sure you install the antenna on the board before you plug it in or attach the battery, because if the antenna is disconnected when the node is powered on, it can damage the radio. Now that we've installed the board into the case, we need to make sure the firmware is fully updated, and we're going to use the Meshtastic web flasher to do that. I'm going to connect this to my computer using a micro USB cable, and then go to flasher.meshtastic.org using a Chromium-based browser such as Google Chrome or Microsoft Edge. We can select the T-Beam in the first dropdown, and then we'll select the target firmware version in the second dropdown. I'm using the latest stable version, which as of when I record this is 2.5.6 beta. Now we'll go ahead and hit flash, and we can watch the progress in the serial monitor. Okay, with the new firmware flashed, we're going to go over to the web client at client.meshtastic.org to configure the node. We're not going to change anything under device, position, or power, but we are going to go into the network and configure Wi-Fi. This is because this node is one of my gateway nodes, and I'll be using it to extend the mesh to the internet via the public Meshtastic MQTT server. Now we're going to hit save and let the device reboot. The node will reboot after every configuration change. Okay, next let's go into display. The only thing we're changing here is the display units because I think in imperial instead of in metric. Again, I'm going to hit save and let the device reboot. Now we're going to get into the important things. Under LoRa, we need to set the region so the radio broadcasts in the allowable frequency range. I'm located in the United States, so I'm going to select US. If you're in a different region, you will need to select the correct setting so you are in compliance with your local regulations. While we're on this page, we're also going to change the maximum allowable hops from 3 to 5. Almost everyone will only need to select 3 on this page, but I'm increasing it due to the distances I need the packets to travel to reach some of my family members. Not all of my nodes will be configured this way, and if you don't have a very specific use case like mine, don't adjust the setting from the default of 3, as it uses more airtime if you increase it, and that's not fair to everyone else. We're also going to change the OK to MQTT setting on here to true, and then hit save. That's the last of the radio config options we're going to be changing, but we are going to be changing another couple of things in the module configure settings. First, under the MQTT module, we're going to enable MQTT. This will let us send and receive messages from the local mesh to the extended statewide mesh. We're leaving most of the settings here as the default, but we are going to change the root topic to include my state, Missouri. Okay, now I'm going to hit save again and reboot. The last module to configure is the neighbor info module. I'm going to enable this and set it to 3,600 seconds, which is once per hour. This is just a handy way to see what else is out there and connected to the mesh. Okay, that's it for the main configuration. The last thing to do is to give this a name and an identifier. For this one, I'm going to call it the TechHearth Demo Gateway and use a short identifier of THDG. And that's it. We now have a fully configured Meshtastic node, and we can start chatting with others on the primary channel, either through the web client, which we're using to configure it, or with the web client hosted locally at the IP shown on your T-Beam's OLED display. I hope that was helpful to you, and that you come back to join me again in the future. I'll be walking through the setup of both the Lilygo T-Deck and the Rack Wireless WizBlock in the coming couple of weeks. And also coming soon is a look at radiation detectors and how they work. So I do hope that you like, subscribe, and come back to join me again here at the Tech Hearth.